Hello there, Mr. Sutton here with the IM3 Honors Pre-3 Extra Practice Answers on dividing complex numbers.
To find the conjugate of this complex number, we have to change the sign of the imaginary term. So this is now going to be -5 minus 4i. To find the conjugate of this complex number, we're going to change the sign of the complex term. So now we will write -19 plus 12i. To simplify this complex number, we need to get the I out of the denominator. Since there's just a single term in the denominator, we can do this by multiplying by I over itself. So that's going to give us 4i over 9i squared. Since I squared is really -1, we can reduce this to -4i over 9. To simplify this quotient, I need to get the I out of the denominator. Since I just have a single term in the denominator, I do this by multiplying by I over itself. Distributing the I in the numerator, that's going to be 6i minus I squared. And in the denominator, that's going to be 4i squared. Simplifying the numerator by changing I squared to positive, or actually -1, we've got minus -1, so that's actually a positive 1 plus 6i in the numerator. And in the denominator, this is really 4 times -1, so this is -4 down here, and we can't reduce that anymore. For this problem, to simplify, we need to get the I out of the denominator. To do that, we just multiply by I over I. Since we just have a single term in the denominator, nothing more complicated is needed here. So we've got then -I over 5i squared. And I squared is really -1. That cancels out the negative out in front of the fraction. So we really just end up with positive I over 5. To simplify this quotient of complex numbers, we need to get the I out of the denominator. Since we have two terms in the denominator, to do that we have to multiply by the conjugate of the denominator. So we're going to be multiplying the numerator and denominator by 5 minus 6i, because that is the conjugate of the denominator. Alright, so let's do the numerator first. Big fraction here. We're going to have to, well actually there's some shortcuts we can use, just kind of a coincidence, but in the numerator you might notice that we're actually multiplying 5i, or 5 minus 6i by itself. So we can use the shortcut a squared minus 2ab plus b squared, or you can FOIL it out and combine like terms. I'm going to use the shortcut though. So we have 5 squared giving us 25. Multiplying these together and doubling it, that's going to be 2 times -30i, so -60i. And then we square the last thing, so that's going to be plus 36i squared. And again, you could have arrived at this by FOILing it out and combining like terms. Alright, in the denominator we have a plus b times a minus b, so we can use a squared minus b squared for a shortcut down there. So that's going to be 5 squared for 25, and 6i squared is again 36i squared, but now we're subtracting that. And let's do a little bit of simplifying. In the numerator, 36i squared, well, since I squared is really -1, that's really minus 36 up there. And in the denominator, we now have -36 times -1 here, so that's positive 36 to go with the 25 that's already down there. Back in the numerator, 25 minus this 36 would give us a -11 to go with the -60i. And in the denominator, 25 plus 36, that's going to be 61. There's no common factors between 11, 60, and 61, so this is as good as it gets. To simplify this quotient, I need to make sure there's no imaginary numbers in the denominator. To do that, I have to multiply the top and the bottom of the fraction by the conjugate of the denominator. So I'm going to multiply by 7 minus 10i over itself. In the numerator now, we just have to distribute the 2i. So 2i times 7 is 14i. 2i times -10i, that's -20i squared. And we'll simplify a little bit more up there in a moment. In the denominator, we have a plus b times a minus b. So we can use a squared minus b squared there. 7 squared is 49. 10i squared, that's going to be 100i squared, and we're subtracting that. Now I can simplify those I squareds to -1s, so this -20i squared is really a plus 20. So we have 20 plus 14i in the numerator. And in the denominator, minus 100i squared is really plus 100. And we can simplify a little bit further. 49 and 100, that gives me 149. And it doesn't look like there's any common factors that I can reduce by, so this is done. To simplify this quotient of complex numbers, I need to get rid of the imaginary number in the denominator. Since I only have a single term down there, I can do this by just multiplying by I over I. So distributing the I in the numerator, that gives us negative 3i plus 10i squared, which will simplify a little bit more in a moment. And downstairs we have negative 7i squared. Back in the numerator, I squared is really negative 1, so this is going to be a negative 10, along with that negative 3i up there. Downstairs we have negative 7 times negative 1, giving us positive 7, and we can't simplify this anymore.